we're on to question 7. Question 7 is the first of our problem-solving context and applications questions. And this really is one of these, I suppose what some of us would know as classic project maths questions, where there's a bulk of English in there, there's a load of vocabulary, there's these questions. Really, your first advice to students is you got to read it a couple of times. Take your time with it, highlight the key words, the key bits of information, and go from there. It says a transition in your class is hearing about the rules of ice hockey for the first time. They're given the following diagram of an ice hockey rink to help them with their lesson. Students are told that the width of the goal is 1.83 meters. In their maths class later that day, they do some further calculations using a model of the ring. A student draws the following diagram with measures given. Calculate the angle LQR and the size of the angle, the measure of that angle, correct to the nearest degree. So even though in this case it seems like this is all to do with a ice hockey ring, and it is, once you've gotten this far, the actual story isn't that important. It's just the maths. We have a triangle. We have no reason to expect it's a right angle triangle. We have to calculate the angle at Q. So what are we going to do? We have 3 sides. We're going to use cosine rule. So again, as we mentioned in an earlier video, we're looking for the angle at Q. So the angle LQR is obviously going to be here on my right hand side, but my side across from that, the 1.83, that is this side that's by itself getting squared. So 1.83 squared is equal to 21.22 squared plus 19.63 squared minus twice 21.22 times, that's 19.63 times the cosine of the angle that we're looking for. So what can I do? Well, in this case, what's happened here is we've done a couple of steps in one, right? But what you'll end up with is you'll end up 21.22 plus 19.63 squared, both of them squared. And then you'll be subtracting away the minus 1.83 to be squared, and you'll end up dividing by the coefficient on the cos. So 2 times 21.22 times 19.63 cosine LQR. And you'll have gotten as far as here. When you typed all that into the calculator, you're going to get 0.999. You're going to get the inverse cos of that number, 0.999, and you're going to get an angle of 2.54. So you look back at the question, it says to the nearest degree, and to the nearest degree it is 3 degrees. Okay, so it's 3 degrees is my answer. And, you might be wondering again, what does the 3 degrees mean in this case? Well, we're not 100% sure what exactly it refers to, but that's the answer to the question. I was a 10 marker. So we keep going. Again, here's a bit more context. Near each goal, there is a face-off spots, or there are face-off spots at the center of a circle with 4.57 meter radius. A sponsor who imports sports gear has painted a sports helmet inside the circle and has centered it at the face-off spot O. The angle AOC is 2.17 and key radians. OA and OC are equal to each other. They are 3.36 meters. So that's these two sides here. They're obviously radii of that smaller circle. Calculate the area inside the circle which has not been painted, correct to the nearest square meter. So, a lot of students will be a little bamboozled at this point because they'll have read all this English, they might be finding it a bit tricky, but you just got to take your time with it. The circle itself has an area, has a radius of 4.57. So the area of the whole circle is pi times the radius squared, pi times 4.57 squared. That's 65.61. The area of the sector, So that's what's in green is a half r squared theta, where theta is in radians. Now we actually, I could call this guy theta there. We actually don't know what theta is yet, but I could call that guy theta. We don't know what theta is yet, but I've labeled it there in orange. But we know that this is 2.17 radians. We know there's 2 pi radians in a full circle. So therefore, 2 pi minus 2.17 would be equal to 4.11 radians. That's my angle. So I'm going to have a half. The 4.11 is your theta, and your 3.36 is your radius, and you're going to be squaring that. And when you put that all together, you're going to get 23.20. You subtract that away from the area of the full circle, and you get your answer 42.41. Let's just have a look back at the question again. To correct the nearest square meter, it's going to be 42 meters squared. 42 meters squared. And that was a 15-mark question. So I'm going to say tougher than it looked, or no, tougher than it looked? No, the other way around. Easier than it looked. But you had to be familiar enough with your radians, the fact that there's 2 pi radians in a full circle, and then you just had to take your time with it. Look at it, in the end of the day, it's that same old technique we've had all the way back from junior cert, where you have, a shape and you find the area of the full part. You find the area of an inner part, you subtract one from the other, and you're left with something, some other area, the area required. So we've come across it quite a lot. As part of the lesson, students watch some footage of American ice hockey team in training. During one of the drills, a player attempts to flick the puck into the back of the net. The height of the goal is 1.22 meters. The player stands at the side of the goal mouth so that the puck is 3.5 meters from the goal line. And that's PG is 3.5 meters. So that's my 3.5 meters here. 4.9 meters is the measurement to the near post. So that's PL. 5.3 meters is the measurement to the further post. So that's PR. The player aims to point the puck at T, which is 30 centimeters below the top of the center of the crossbar. We know the height of the goal was 1.22. So is that going to be 0.92? Which is going to be the height above part C. So it says find GL. So this is my GL. And hence find the angle of elevation TPC. So we will draw that in a moment. Okay. So there's a lot in there. You got to read it a couple of times. Take your time with it. Maybe at times you might want to draw out individual triangles. I'm going to highlight them here rather than drawing them out separately. But in this case here, I'm going to find GL using Pythagoras' theorem. So 4.9 is my hypotenuse. So I work out GL to be 7 root 6 over 5 meters. Okay. I can then figure out GC, that full length there, because it's going to be GL plus LC. And we know that LC is the 1.83 divided by 2. So when I put that all together, it's going to be 4.344 meters. Knowing that allows us to figure out PC, because we know what PG is. So it's another Pythagoras' theorem to find out PC. I'm going to get to 5.58 when I work this out. And now this is going to be key to us because it's going to allow us to figure out what we were looking for. And again, I think is this for the third time where we go, there's my 0.92. So that's my height. Oh, in this case, I was going to say we're going to use cosine rule, but no, we're not, because in this case, we're dealing with a right angle triangle. I was nearly falling into that same trap that I often talk about. So in this case, we're dealing with a right angle triangle. Does it necessarily look like a right angle triangle as you look at it? Maybe not. And the reason is because you're looking at it at two-dimensional. It's talking about it like it's a three-dimensional sketch, but it's on a two-dimensional page or screen. So therefore that angle doesn't necessarily look like 90 degrees, but it is because it's a horizontal meeting a vertical. So it must be right angles. The 0.92 is going to be the opposite because it's this angle we're looking for. The 5.58 is going to be my adjacent. Which of the ratios uses opposite and adjacent? It's tan. So the tan of the angle is the opposite over adjacent, 0.92 divided by 5.58. I'm going to get the inverse tan of that, and I'm going to get 9.36 degrees. And that's my answer. Now, there was a lot of work in it. It was 15 marks. I suppose overall, what was it? It was Pythagoras' theorem done repeatedly, and then a trigonometric ratio. So the mathematics, when you look at it, aren't the most complicated, but to get all the way without making a mistake and to be able to see it all, that's the bit that's tricky. Wow, we're back here. Noah's still going here. One of the students is Noah. He's cycling home from school. On the way home, he hears a click-clack sound. While riding his bike, he dismounts to find a small tack embedded in the rubber thread. He knows that the bike wheel has a 66 centimeter diameter. Once he's home, he turns it and observes the tack on the tire rotating around the central wheel hub. The height h of the tack relative to the center hub may be given by this. H is equal to 33 sine 45t. Okay, so h is equal to 33 times the sine of 45t, where h is the height in centimeters and t is the time after the wheel begins to rotate. After how many seconds will the height of the tack be 30 centimeters above the center of the hub? So look, there's a lot of English in there. I often wonder if English wasn't your first language, would at times the papers might be very difficult. You might be looking at click clack and wondering what does that mean. It doesn't mean anything particularly, does it? It's just that sound that the wheel might make as it's rolling along with something stuck in the tire. But here's the thing, as I often say, if you don't know what to do what you know. It's telling us that the height is 30 centimeters above the center. So wherever 30 centimeters might be, we don't know where it is, okay? But if you don't know what to do what you know. The 30 is the output. The input is t. That's what we're going to try and find. How do I find t? Well, I'm going to isolate my variable. I'm going to divide across by the 33. I'm going to get the inverse sine of 30 over 33. That's going to be my 65.38. But I'm going to be dividing that by 45 to get t on its own. And when I get t on its own, my answer turns out to be 1.453 seconds. After how many seconds? So that's my answer. And it was 10 marks. So in the end, what do we have to do here? Well, it is a trigonometric periodic function question. But in the end, all we had to do was solve the equation. And we only had to find one solution because it was when is it first at that point. So that's going to be in my, the positive version of the inverse sine of 30 over 33. And that was it. That was the end of the question. So look, it was an unusual question with the amount of English in there. What we figured is, like, some people will like it. They'll go for a question like that, and other people will rule it out completely. You might be looking at back now on the video to kind of learn a little bit from it, to practice for the actual exam. And I think you'll find that once you've read through it, highlighted the keywords, you'll see that maybe it's not quite as bad overall as it looks. Okay, let's move on to the next problem solving question, question 8. Something very different.